Okay, you can pause the video to study the question first, alright? And then I will begin with the solution to this question. Now, the thing is, okay, this is integration, and integration actually is to find the area under the graph. Let's say if I integrate ex dx, right, from 0 to 1, actually I'm finding the area under this y equals to ex graph. Now, this question aims to show us that actually this is the why integrate how integration actually works. So he shows us the proof of the integration. So now let's attempt to show to this question. So 0 to 1. So for this type of question, you have to be observant. So first, so what are the areas of the sum of the areas of the rectangle? Right. First thing we note that the area of each rectangle is the number, is the y value at here. So for example, let's say y. So to find the area, I just take base times height. It's make use of very basic knowledge. So y equals to ex, right? So when x equals to 0, y is equals to e0, right? So e0 is actually, so y equals 0, y x equals 0, y is equals to e0. E0 is actually equals to 1, right? And that means that the area of this rectangle is what? Okay, this is 3n, and the rectangle each of width 1 over n. So this must be the length 1 over n. But do I take 1 over n multiplied by 1, right? Or 1 over n multiplied by e1 over n. So what is the... So of course you see that the rectangle is, the height is the length. So for example, what would be the y value of this? So since y equals to ex, so this would be the x value, n minus 3 over n, obviously. Alright? Okay, so show how the total area of all the n rectangles is this. So how many rectangles do we have? Right, so if we try to express this in terms of the summation notation, what would it be? So that would be, okay, so if I want to find the total area of all n rectangles, I could just list out the few terms to get the picture. So first rectangle would be 1 times 1 over n, so it will be my 1 over n. Then the second rectangle would be plus, what is the value of this? This would be e to a power, this coordinate here would be 1 over n e to a power of 1 over n. So therefore, to find the area of this rectangle would be, since this length is 1 over n, so base times height, so it will be 1 over n times e 1 over n, correct? And what would this coordinate be? This coordinate will be 2 over n. So the third rectangle would be plus 1 over n, the length here, times the height, which is e2 over n, e2 over n. And then finally, the last rectangle would have height. What is the height of the last rectangle? It is plus 1 over n e times e n minus 1 over n. And not e1, because this is the height of the last rectangle, should be this, right? And no, there are many rectangles in between, so I would just e 2 over n plus ... 1 over n e n minus 1 over n. Alright, how many, then I look at this one, they say how many rectangles do you think there are? From 0 to 1, and each is length 1 over n. So how many rectangles there are? Of course, you take 1 divided by 1 over n, the width width of each rectangle, the total length divided by the width of each rectangle will give me the total number of rectangles in this. So there are n rectangles, right? So therefore here we have n terms. Since every term has a 1 over n, I could just factorize it out. So I have 1 plus e 1 over n plus e 2 over n plus so on and so forth, e n minus 1 over n. Correct? So we have this n terms over here. So 1 over n. So what kind of series is this? If you have learned arithmetic progression or geometric progression before, geometric progression means every term in this series is a multiple of the previous, is a common multiple. So for example, if we have a GP, this is like, what is e1 over n multiplied by 1 will give me e1 over n. And e1 over n multiplied by e1 over n, which is this, will give me equals to e1 over n plus 1 over n by the power laws. So it will give me e2 over n, right? So therefore the common ratio between this and this is e1 over n, and we can say the same for the rest. To the third term, this would be 3 over n. So if I multiply e1 over n to e2 over n, what I get is e1 over n plus 2 over n on top. So I will get e3 over n by the power laws. So therefore, that means that this is a geometric progression in which every term in the series, every consecutive terms in the series is obtained by multiplying a common ratio to the previous term. In this case, the common ratio is e to the power of 1 over n. So for this type of geometric series, when I want the sum of the n terms, there is a formula. That is the first term, bracket 1 minus the common ratio to the power of n, where n is the number of terms, and over 1 minus r. In this case, the number of terms happen to be n. So I will just leave it here. So what's my common ratio? My common ratio I've just now already obtained. It is e to the power of 1 over n. So e to the power of 1 over n to the power of n. Right, that's substituting. Common ratio is my r, so I'm substituting e1 over n into my r. So minus 1 n a n this. So what is my first term? My first term in this series is a. A is the first term in the formula. So 1 is the first term in this entire series. So I multiply by 1. So n 1 minus e to the power of, again my r is e to the power of 1 over n. So if you are not familiar, if you don't know the concepts behind arithmetic progression and geometric progression, you won't be able to do this question, right? So we have so if you want, you should get your basics before coming to do this. So therefore I have 1 minus e to the power, that means my sum to n terms is just this part, right? So I'm just going to put this formula here inside here. So the equal sign is a bit misleading. This part is only for this part, right? It has nothing to do with this. So this is for this, right? Yep. So there's not, this part is for this part. So this thing Sn is for to describe this. So I have 1 minus e to the power 1 over n to the power of n is just n and n would cancel away. N would multiply with 1 over n. So I get e to the power of 1. Right. And this would give me 1 minus bottom is minus e to the power 1 over n. So that's how I get equals to. Now you see that what they want us to show is the reverse. So I just need to multiply a negative on top and below. So multiply -1 over -1. This term is just 1, so I'm not changing anything. So this will give me 1 over n. Minus 1 multiplied will give me e to the power 1 over n minus 1. Alright, and then the top will become e minus 1. E to the power 1 is just e, so e minus 1. So then this is just equals to n multiplied to the bottom, so e 1 over n minus 1, and top would be e minus 1. So I have managed to show that the total area of all the rectangles is this. Okay, so next step, so I'm going to erase all of this and we come to the second part of the question. Take a minute to look at the second part of the question. Right, so by considering the area of the region bounded by the curve y equals to ex, right? That means this curve y equals to ex, x equals to 1, x equals to 1 is this line, right? And the axis, that means this line, this axis and this axis, show that e1 over n greater than 1 plus 1 over n. Okay, now how do we find the area of the region using integration of this area using integration? Using integration, what we do is we integrate from 0 to 1 the function that we want, so is ex dx. We know that this area of the this entire area is greater than the area of what we found earlier, e minus 1 over n times e to the power 1 over n minus 1. This is the area of sum of area of all the rectangles, and this is the area of the region bounded by this axis and the curve, and this line x equals to 1. So if then when I do this, I should be able to get to this. Okay, because this area is indeed larger than the sum of the area of the rectangles. So because there are gaps here, you see, there are gaps here, right? So the area here is larger than the sum of the area of the rectangles. So when I integrate ex, right, okay, I still get ex. And I have 1, 0, right, greater than e minus 1 over n over e n times e, okay. It's like this. So this will give me e to substitute with 1 minus e substitute with 0. This minus is by default when we do this kind of integration. So and this would be greater than e minus 1 over n times e 1 over n minus 1. And this value is just 1. E0 is just 1. So I have e minus 1. Okay, e minus 1 and greater than e minus 1 over n, e 1 over n minus 1. Alright, what is e? E is a calculator. If you substitute in the calculator value, e is about 2 point something, right? 2 point something. So 2 point something minus 1 is a positive number. Since they are a positive number, I can divide it on both sides without changing the inequality sign. So this would cancel with this. Alright, and that's it. Right, so we are quite close to the final answer. So we have this already. So we have 1 greater than 1 over n e 1 over n minus n. Oh, okay. So or we would prefer, if we prefer, we should still keep it in this form, right, and see what happens. Okay, we are quite close. N is a positive number. There are n rectangles, so n is positive number. Positive number I can just multiply over, so I get n greater than 1 over e 1 over n minus 1. So we are quite close indeed. So e is always a positive number, and e1 divided by n is a fraction. When e to the power of a fraction is a negative number. It's definitely a negative number because E1 is E0 is 1. Okay, so not necessary. This is a positive number. So alright. And how do I get to this? If I can't guarantee that this is a positive number. Can I? Not sure. Okay, never mind. What about if we... Okay, I'll pause here to think. I can skip over. Yep, E1 over n is definitely a positive number. Alright, it's definitely a positive number because E1 over n is here, right, which is slightly more than 1. Right, E0 is 1, E1 over n is 1 over n is a positive number, so it's greater than 0. So E1 over n is a value that is higher than 1. So this definitely is a positive number. Because E1 over n is greater than 1, then the greater value minus the smaller value, this would definitely be a positive number. So I would multiply it over here. Minus 1 greater than 1 over n. So since n is a positive number, I can divide over without changing the inequality sign. This one I multiply over. So now E1 over n is greater than 1 over n. This minus 1 I bring over becomes plus 1. I get to show that E1 over n greater than. So that's all.